Welcome to Complexity Made Simple. My name is Paul Allen, and the subject of today's video newsletter, well, this is a video for all the UK manufacturers out there. During these times of lockdown, we have time on our hands, we have volumes that are down, we have time to learn. I want to talk to you about one of the greatest tools you can learn while you have the time, so that when we get back to full power, UK manufacturing is ready to eat the competition alive. We are going to talk about design of experiments. Design of experiments, also known as DOE. Another way to describe this is it is the fastest way to find out. If you have a process and you have dials, settings, speeds, feeds, temperatures, pressures, all kinds of nonsense, you have features and things that you're trying to please the customer with. What you want, of course, out of that machine is the very best settings, fastest, cheapest, best quality, so that you eat your competition alive and you make piles and piles of cash. Only DOE can find you the very best settings. Let me give you a little example. And then we'll talk about other examples, and I'll show you how complicated. By the way, your skill can't do this. Your processes are way too complicated for your skill to find the best settings, not settings that work. We are looking for the very best settings. So I'm going to give you a little example. I was sent a query by someone that watched one of my other videos. It was a research engineer over in a US university, and all he was doing was working with a 3D printer. So 3D printing's kind of exploded. Everybody seems to have one these days. It was relatively new technology 5 or 10 years ago, but now it seems to be the weapon of choice in most companies for various bits and pieces that people want to make. And this engineer wanted to understand how to make the printer work better, and what he was particularly interested in, he was only interested in surface finish. Now I'm going to add some other things in a moment, but he gave me 3 variables that he was going to play about with in order to understand how surface finish. Now this is something that manufacturers have to do all the while. You've got machinery and you're trying to understand how to best set them up to get the best quality, cheapest item out of the machine. So this is a problem you face every single day. DOE will do this fastest and literally guarantees that you find the best settings. Now the 3 variables that he gave me, one was called the infill percentage, and he was going to take that percent from 5% up to 100%. He gave me orientation. Now what the orientation was about was he was going to produce the part. He could produce the part flat in the machine, or he could produce the part standing up. So I call that 0 degrees and 90 degrees. And then finally, he had nozzle diameter. Okay, and it was down at 0.2 of a mil up to 1 millimeter in diameter. So they were the three variables. He was only interested in surface finish, but of course he could have been interested in other things. Maybe the weight of the part, maybe the strength of the part. Of course, something else we might be interested in. Might be interested in the cost of the part. Yeah? So there might be more outputs. He only gave me 1, but typically, and of course this is your challenge, often you're trying to find a sweet spot. It's even more complicated when you're trying to find a sweet spot. Now this is a relatively simple situation, but even here, look, I've got 95 choices on the infill. I've got 2 choices on the orientation, and if I take this up in 0.1s, I've got 8 choices for the nozzle diameter. If I multiply that up, it comes to approximately 1,500 different ways of setting the machine up. Now, how does he find the best settings? Does he test all 1,500? Does he guess? Does he try to use skill? Well, how about this? DOE says 8 tests. That's all he needs. But he needs the right 8 tests. This is what this is going to tell you. It's going to tell you the right 8 tests to do to find out the answer. How about that? And by the way, it will do this for any process. If you come up with variables, you tell me what the inputs are, what the dials are, we can come up with any experiment and it will find the information out as fast can be. Cheapest settings, fastest settings, best quality settings, and you can go and eat your competition for breakfast. That's what DOE does. Now let's take a look at another example that's even more complicated than this. Something that maybe lots of UK manufacturers do. Maybe you do injection molding. Let's take a look at this example. I want to just think about how complicated the problem currently is. Because what do we have? We have 1, 2, 3, 4, 5, 6, 7. We have 8 variables there. And you'd think, well, it's only 8 dials, it's only 8 settings. It can't be particularly difficult to find the best settings. Now I know that you can find settings that work on a machine. That isn't what we're trying to find here. We are trying to find the very best settings, the fastest settings with the best quality. This isn't about a set of settings that just work. They already have that. Okay, so we are trying to find the very best settings. So 8 variables. Now it looks really easy, doesn't it? But actually what most people do is they only count the variables. They don't look at the number of combinations. So look at this. You have 100 choices multiplied by 50 choices multiplied by 44 choices by 225 choices by 90 choices by 20 choices by 400 choices. If you multiply that lot through, this isn't 8 variables that you're looking at. And I've just worked this out on a calculator. Oh dear. It's 1.5 trillion choices. That's the complexity of trying to find best settings. This cannot be done with someone's skill. Someone cannot carry this model in their head and understand what the best settings will be to get the fastest process with the best capability. It just is not possible. Only DOE can interrogate that design space, using mathematics essentially to interrogate that design space. Okay, 1.5 trillion different ways of doing it. There are 1,500 ways of doing this. 1.5 trillion. By the way, DOE, 20 tests. Out of those 1.5 trillion ways of doing it, all it's going to ask you to do is 20 tests, then it will recommend the best settings. It's the fastest way to find out. Why wouldn't you go out and learn design of experiments whilst you're in lockdown and you have piles and piles of time to do this? Now, you can go and look this case study up. I follow the case study through, I show you the 20 tests, I show you what they achieve on the case study. You just have to search on my YouTube channel for something called moulding, perfection, and it will show you how it's done. But it doesn't matter, by the way. All of your processes are the same. You all have a money-making machine with inputs and outputs that you're trying to optimize. If you tell me what are the dials, time, temperature, pressure, speed, type of material, all sorts of different things. If you tell me what the variables are, I can tell you which DOE you should do to learn the most in the fastest possible way and for you to make more money, because that's what we want UK manufacturers to do. We want you to go out and smash the competition. Now, if you want to learn how to do DOE, you can go and buy my latest book. If you go on lulu.com, you will see Design of Experiments for 21st Century Engineers. There's my name there, Paul Allen. You can buy the book from lulu.com. It's really practical and easy, and you will save pots and pots of cash. If you read the book and you want to go further, you'd like me to come and train at your organization, just drop me a line either on the video below or on LinkedIn. We'll organize for me to come in and train your engineers to do this. But if you don't want to spend any of that cash, if spending 20 quid on a book is too rich for you right now, drop me a line. Tell me all the variables in your process. Tell me what you'd like to know from your process, and I'll tell you what DOE to do to learn the most amount of knowledge and make the most amount of money out of your machine. That's my challenge. So come on, UK manufacturers, let's go learn a new skill. Let's get back to work pretty soon, and let's smash the competition out of the water with Design of Experiments. I look forward to hearing from you soon.